Hello everyone, I'm Hyunchul Kim. I will present the project I did with Kasper Hornbæk and Byungjoo Lee. In human-computer interaction, the user may perform a button input through two different strategies. First, reactive strategy. Users can passively react to the output of the computer. In this case, the button input is planned after the output is observed. The input to output time interval are modeled with X-Gaussian or log-normal distribution with a long tail. The key metric for usability evaluation is the mean of the distribution. If the user reacts to the computer's output faster, the mean of the distribution decreases. Second, proactive strategy. User can provide an input in anticipation of computer's future output. In this case, the button input is planned before the output is observed. The IOIs are modeled with Gaussian. The key metric is the standard deviation of the distribution. If the user predicts the timings of the output more precisely, the standard deviation decreases. Each input strategy has been actively studied. However, two input strategies are mixed when numerous outputs are given in everyday interaction. To analyze the button input properly, we should know the degree and characteristic that the user utilizes reactive or proactive strategy respectively. For that, we propose the technique analyzing screen recording and input logging through EM algorithm. Let me talk about the pipeline of our technique. At first, in our technique, the screen is recorded using open broadcaster software. The input is logged jointly when the screen is captured. Button type, timestamp, whether pressed, cursor coordinates are logged. Then input filtering is performed. We extract the beginning of a button press, which is assumed as the input activation intended by the user. Next, output filtering is performed. The resolution of a video is downscaled for efficiency. Then, in every pixel, the perceptible visual changes are extracted by thresholding the absolute difference between the previous and the current value in CIE-lab color space. Then, we pair all visual outputs and its nearest input on the time axis. After calculating IOIs of the pairs, we remove the most frequent bin of the negative region assumed as the system feedback. We assume IOIs are sampled from a certain probability distribution, and the distribution can be expressed as the sum of several sub-distributions describing IOI. The first is the reactive button input distribution. The second is the proactive button input distribution. The third is the irrelevant button input distribution. We fit the actual IOIs to our model through the EM algorithm. The EM process estimates which sub-distribution the IOI belongs to, and which parameters maximize the likelihood of the distributions alternately. As a result, we obtain the weight and parameter of sub-distribution that best describe the given IOI. We define the reactiveness and proactiveness from the weight of the reactive and proactive distribution. The weight of the irrelevant distribution can be called as irrelevance. Reactiveness, proactiveness, and irrelevance indicates how strongly the pixel is associated with the user's reactive, proactive, and irrelevant input than the others respectively. In parameter, the mean of reactive distribution hat mu r and the standard deviation of proactive distribution sigma p can be interpreted as the key metric in usability evaluation. We conduct the study 1 to analyze two rhythm games with our technique. The independent variable was the game type. In Diner, participants should press the single button to avoid the coming obstacle. Tap Sonic is a multi-button rhythm game with background music. In Tap Sonic, participants press on the corresponding buttons when a polling note is in the target area. In Tap Sonic 1, the sound is turned on. In Tap Sonic 2, the sound is turned off. In analyzing process, multiple types of key input in Tap Sonic were aggregated to reduce the amount of computation. In the irrelevance heat map of dino, two high irrelevant area A and B were observed. A is area where the dinosaur jump. B is not emergent area to avoid collision. In the reactiveness heat map, we can observe that visual event associated with proactive button input in A and visual input causing reactive button input in B. In comparison of Tapsonic 1 and 2, we expected that sigma p will be affected by the existence of the music. However, the difference was not statistically significant. In linear regression analysis, the game scoreboard's participants were predicted from the characteristic parameter with a high coefficient of determination. Next, we conduct study 2 to analyze the self-expanding target design. 12 participants performed the task of pointing to or expanding 1D target using trackpad. The target starts with 1 pixel width and expands following each condition. Easing and duration were independent variables. In easing, 3 levels were given: in, out, pop. Here, easing is the function determining the target width as time passes. In duration, 4 levels were given. Duration means the duration of expanding animation. In analyzing process, we used cursor fixed coordinate by shifting the video frame so that the cursor location becomes the center. As reactiveness is estimated to be high, it seems that our task is generally performed by reactive button input. Interestingly, in condition, head mu R were lower consistently when duration increased, and proactiveness was significantly higher than that of other conditions. From the observation, it seems that the participant moved the cursor closer to the target more quickly, considering the fact that the target expands. Our results show that easing in it might be appropriate to design target easing for quicker input behavior. On the other hand, the sigma p in pop condition was significantly lower than that of in and out condition. It implies that pop condition is more clearly communicated to the participant in proactive manner. Therefore, if the proactive input needs to be supported more, it might be appropriate to adapt pop condition as a easing function. In this work, a statistical estimation technique was proposed that quantified the reactiveness, proactiveness, and the characteristic of user button input. The usefulness of the proposed technique was verified in 2 user studies. In the future works, we will apply our technique to more complex scenarios like esports, editing or graphical software, and etc. This is the end of presentation. Thank you for your attention.